question number 2. We evaluate definite integration 0 to 1 e to the power minus 3t I cap plus t square j cap plus cos hyperbolic k cap with respect to t. So the solution is, we know that the integration of e to the power minus 3t, that is equal to e to the power minus 3t divided by minus 3 into I cap plus integration of t square, that is equal to t to the power 3 divided by 3 into j cap plus integration of sine cos hyperbolic t with respect to t. We know that it is equal to sine hyperbolic t. It is sine hyperbolic t and limit from 0 to 1. Limit from 0 to 1. So integration is this thing. Now on putting the upper limit, we are getting it is equal to minus 1 by 3 is constant. So on putting the upper limit, we are getting minus 1 by 3 is constant. So take it out. It is equal to e to the power minus 3 minus, putting the lower limit, it becomes 1 whole into I cap plus 1 by 3 is constant. Take it out. Putting the upper limit, we are getting 1 minus, putting the lower limit, it is 0 plus it is this into k cap. So it is sine hyperbolic 1 k cap. So that is equal to, so on simplifying, we are getting that it is 1 minus e to the power minus 3 whole divided by 3 plus 1 by 3 into j cap. 1 by 3 into j cap plus sine hyperbolic 1 into k cap. So this is the result of this integration. So next we'll consider the next question. So next it is given 2c, question number 2c. Evaluate limit extends to pi by 2 log of theta minus pi by 2 whole divided by tan theta. So here you see, if we take x is equal to, it is theta tends to. If we take theta is equal to pi by 2, then pi by 2 minus pi by 2 0. So log of 0 is infinity divided by tan 90 it is infinity. So the limit is of the form infinity by infinity. Now by L'Hospital's rule, we know that if the limit f of x by g of x is of the form infinity by infinity, then we take that limit theta tends to pi by 2. What is the derivative of the numerator with respect to theta? It is equal to 1 by theta minus pi by 2. Derivative of the numerator with respect to theta is theta minus pi by 2 divided by derivative of tan theta with respect to theta, that is equal to sec square theta. So it can be written as that limit theta tends to pi by 2, it is cos square theta, divided by theta minus pi by 2. So again this limit is of the form cos 90 is 0, so it is of 0 divided by 0 form. Now since this limit is again of the form 0 by 0 form, so again by applying L'Hospital's rule, we get that it is equal to limit theta tends to pi by 2, derivative of cos square theta, that is equal to minus sine 2 theta whole divided by derivative of theta minus pi by 2 with respect to theta, that is 1. So when theta tends to pi by 2, when theta tends to pi by 2, 2 theta tends to pi, so it is minus of sine pi divided by 1, and we know that sine pi is equal to 0, so it is 0 by 1, that is equal to 0. So limit of this is equal to 0. Here you see that in the next question we have to find the radius of curvature to the curve r is equal to a cos theta. This equation of the curve is given in polar form. So how to find out the radius curvature of a polar form? That we know that the radius of curvature rho to a polar curve of a polar curve r is equal to f of theta is given by rho, radius of curvature rho is equal to r square plus dr by d theta whole square whole to the power 3 by 2 whole divided by r square plus 2 times dr by d theta whole square minus r into d square r by d theta square. Now here it is given that the equation of the polar curve is r is equal to a cos theta. So we will find out dr by d theta. Dr by d theta is minus a sin theta. So next we will find out that d square r by d theta square, which is equal to minus of a cos theta. Now here you see that cos theta is given to be r is equal to, since r is equal to a cos theta, so cos theta from here, cos theta we are getting that it is equal to r by a. So what will the value of sin theta? So since cos theta is equal to r by a, so that implies that sin theta is equal to square root of 1 minus cos square theta. And cos theta is equal to r by a, so sin theta is equal to square root of 1 minus r square divided by a square. Now here on putting radius of curvature rho is equal to r square is equal to your a cos theta whole square, that means it is equal to a square cos square theta plus dr by d theta whole square, that means it is equal to a square sin square theta, its whole to the power 3 by 2 whole divided by r square is a square cos square theta plus 2 times dr by d theta whole square, that means it is a square sin square theta minus r is equal to a cos theta, and d square r by d theta square is equal to minus a cos theta. So r into d square r by d theta square, that is equal to minus a square cos square theta. So minus into minus will be plus a square cos square theta. So we are getting that it is a square cos square theta plus a square sin square theta, it is equal to a square, and a square whole to the power 3 by 2. It is a square whole to the power 3 by 2 divided by, it is a square cos square theta plus a square cos square theta, that is 2a square cos square theta plus 2a square sin square theta. So 2a square taking common, it is cos square theta plus sin square theta. it is cos square theta plus sin square theta, and we know that cos square theta plus sin square theta, that is equal to 1. So it is a square whole to the power 3 by 2, that is equal to a cube divided by 2a square. So a square cancelled out, so it becomes a by 2. So radius of the curvature rho, that means rho is equal to your a by 2. It is the answer. এটা কত 2? Next, in the next question 2e, find the rotation angle theta to remove xy term in the equation x square plus 2 root 3 xy plus 3y square minus 2x plus y minus 1 is equal to 0. Now we know that any second degree equation of x and y, that is ax square plus 2 root 3 xy, plus bxy plus cy square plus dx plus ef plus ey plus f is equal to 0. Any general second degree equation, this equation will not contain the xy term after removing the axis of coordinates to an angle theta. If your cot 2 theta will be equal to your a minus c divided by b. We know that any second degree equation, that is ax square plus bxy plus cy square plus dx plus ey plus f is equal to 0. This second degree equation will not contain xy term if cot 2 theta is equal to a minus c divided by b. What is theta? Theta is the rotation angle. Now, so here what are the values in the given equation? What are the values of a, b and c? Here a is equal to, so here a is equal to 1 and b is equal to your 2 root 3 and c is equal to your 3. So on putting those values of a, b, c, we get that cot 2 theta is equal to a means 1 minus 3 divided by 2 root 3. So that is equal to minus 2 divided by 2 root 3 and it is equal to minus 1 by root 3. So cot 2 theta is equal to minus 1 by root 3 means 2 theta is equal to cot of 120 degree. 120 degree, because we know that cot of 120 degrees minus 1 by root 3. So from here we are getting that theta is equal to 60 degree. So here the required rotation angle theta is equal to 60 degree. That is your answer. So in the next question we have to find out, write the reduction formula for integration of sine to the power nx dx. So in the question paper wrongly it is printed that sine to the power x, here it should be n not x. So in order to find the reduction formula, so we will take that let in is equal to integration of sine to the power nx with respect to x. So that is equal to integration of sin x into sine to the power n minus 1x with respect to x. Now taking sin x as the first function and sine to the power n minus 1 as the second function, and on integrating by parts we are getting that first function sin x extremely sorry. So here you take first function as sine to the power n minus 1x and sin x to be the second function. So on integrating by parts we are getting that first function, it is sine to the power n minus 1x into integration of sin x, that is equal to minus of cos x minus whole integration derivative of sine to the power n minus 1x, that is equal to n minus 1 into sine to the power n minus 2x into again the derivative of sin x which is equal to cos x into integration of sin x, that is equal to minus cos x. So minus into minus, here it will be plus cos of x with respect to x. Now on integrating by parts, we are getting this result. So this can be written as minus cos x into sine to the power n minus 1x plus n minus 1 whole integration sine to the power n minus 2x into cos square x. Cos x into cos x, cos square x, and cos square x can be written as 1 minus sine square x. Integration of this thing with respect to x. Now again, it is equal to minus cos x into sine to the power n minus 1x plus n minus 1 whole integration sine to the power n integration of sine to the power n minus 2x into 1, that is equal to sine to the power n minus 2x with respect to x minus again n minus n minus 1 integration of sine to the power n minus 2x into sine square x, that is equal to sine to the power nx, integration of this thing with respect to x. But here you see that in is nothing but integration of sine to the power nx with respect to x. That means this is our in. This is equal to our in. So in on the left hand side, in is equal to this thing. So on taking this term to left side, we are getting that plus 1 plus n minus 1 whole into in is equal to cos x into sine to the power n minus 1x plus n minus 1 and the integration of sine to the power n minus 2x can be written as I subscript n minus 2. So here 1 plus 1 minus 1 cancelled out. Now in is equal to how much? In is equal to cos x into sine to the power n minus 1x divided by n plus n minus 1 divided by n whole into I subscript n minus 2. So it is the reduction formula in, or the integration of sine to the power nx with respect to x. So here you see in the next question, it is given that so that the vector valued function r of t, that is 2t, 5t, t square plus t is continuous. That means here it is given that r of t is equal to 2t I cap plus 5t j cap plus t square plus t k cap is continuous. So let us examine the continuity of this function, vector valued function, at t is equal to t0, where t0 is any real number, t0. So let us examine the continuity of r of t at t is equal to t0. So by definition, when this function r of t will be continuous and t is equal to t0, it will be continuous. This function r of t will be continuous and t is equal to t0 if limit t tends to t0, r of t that is equal to r of t0. That means when the limiting value will be equal to your functional value, then only this function will be continuous. So first of all, we will find out that what is the value, functional value, r of t0 value will be how much. So r of t0, it is equal to here, it is equal to your 2 t0 I cap, functional value is 2 t0 I cap plus 5 t subscript 0 j cap plus t0 square plus t0 whole into k cap. It is the functional value. Now we will find out next the limiting value. So again limit t tends to t0, t tends to t0, r of t. That means limit t tends to t0, What is r of t? R of t function is 2t I cap plus 5t j cap plus t square plus t whole into k cap. Sorry, t square plus t whole into k cap. Now we can take that limit h tends to 0, 0 plus. Instead of t, we can put t0 plus h. So it becomes 2 times t0 plus h whole into I cap plus 5 into t0 subscript h. So, t0 plus h into j cap plus t0 plus h whole square plus t0 plus h whole into k cap. So now here you see that when h tends to 0 plus, this will tend to how much? It will tend to t0 plus h, that will tend to t0, and this t0 plus h, it will also tend to t0, and when h tends to 0, this will tend to t0 square plus t0. That means it is equal to 2 times t0 I cap plus 5 times t0 j cap plus it is t0 square plus t0 whole into k cap. So that is equal to your functional value r of t0. That is equal to your functional value r of t0. So since the limiting value is equal to functional value, hence this function, this vector valued function is continuous at t is equal to t0. So it is, in general, it is continuous for every real value of t. So it is always a continuous function. That is 2h. So that the asymptotes of the cubic x square y minus xy square plus xy plus y square plus x minus y is equal to 0 got the curve again in 3 points which lie on the line x plus y is equal to 0. That means we have to prove that the asymptotes of this curve, the asymptotes of this curve got again this curve in 3 points which lie on the line x plus y is equal to 0. So first of all we'll find out all the asymptotes to this curve. Now how to find out the asymptote, horizontal asymptote? In order to find the horizontal asymptote, we have to first divide the entire equation with the highest power of x. With the highest power of x. In order to find the horizontal asymptotes, we are always to divide. We have to divide the entire equation by the highest power of x. And what is the highest power of x? That is your x square. And if we take that limit x tends to infinity, then that will give you the horizontal asymptote. So here you see that if we divide the entire equation with the highest power of x, that is by x square, and if we take limit x tends to infinity, then all the terms will tend to 0 except this term, that means y is equal to 0. We are getting that y is equal to 0. This is the horizontal asymptote. It is the horizontal asymptote. So the horizontal asymptote of this curve is y is equal to 0. Now here we will prove that this asymptote again cut this curve at the point and which is lying on the line x plus y is equal to 0. So that means you have to find out the point of intersection of this horizontal asymptote with the given curve. So how can you find out the point of intersection of asymptote with the given curve? So we have to solve this equation. Now for y is equal to 0, if you put y is equal to 0 in this equation, then again we are getting that x is also equal to 0. So that means here you see that 0, 0 is the point of intersection. 0, 0 is the point of intersection of this horizontal asymptote with the curve. And this point 0, 0 is lying on the curve, lying on the straight line, whose equation is x plus y is equal to 0. Because 0, 0 coordinates are satisfying the equation of the line x plus y is equal to 0. So we are getting one point, that is first point, that the horizontal asymptote is meeting this curve, is cutting this curve at 0, 0, and 0, 0 is lying on the straight line x plus y is equal to 0. So again, so it is the first point. The first point is 0, 0. So next we will find out the vertical asymptote. Vertical asymptote. So when we have to find out the vertical asymptote, similarly we have to again divide this equation by the highest power of y. Highest power of y. What is the highest power of y in this equation? Here it is y square, here it is y square. Highest power of y is y square. So you have to divide this entire equation by the highest power of y square, and you have to take limit y tends to infinity. So when you will take limit y tends to infinity, that will give you the vertical asymptote. So here you see, when you will divide this entire equation by the highest power of y, that means by y square, so you will be getting here its coefficient is minus x plus 1, and rest term will tend to 0. So the vertical asymptote is nothing but that is equal to your minus x plus 1 is equal to 0. This is the vertical asymptote. It is the vertical asymptote. Vertical asymptote. So vertical asymptote is x is equal to 1. Vertical asymptote is x is equal to 1. Now here you see that after finding out the vertical asymptote, again we have to find out the point of intersection of this vertical asymptote with the given curve. So in order to find out the point of intersection, you have to solve the given equation of the curve and the equation x is equal to 1. So here you see, for x is equal to 1, how much you are getting here? For x is equal to 1, you are getting that y minus y square plus y square plus 1 minus y is equal to 0. Putting x is equal to 1 in this equation, we are getting this thing. So here you see, it is equal to, here y square cancelled out, y cancelled out. That means you are getting that y is equal to minus 1. So for x is equal to 1, this equation gives you that y is equal to 1. That means what is the point of intersection of this vertical asymptote with the given curve? The point of intersection is nothing but 1 minus 1. 1 minus 1. It is the point of intersection of this vertical asymptote with the curve. Now this point, whether this point of intersection is lying on the line x plus y is equal to 1. Yes, it is lying, because for x is equal to 1 and y is equal to minus 1, is equal to 0. The line equation is x plus y is equal to 0. Now since the coordinates of this point 1 minus 1 is satisfying the equation of the line, that means the point of intersection 1 minus 1 lie on the line x plus y is equal to 0. So here we have got 2 points. One is 0, 0 and other one is 1, minus 1. Those 2 points are the point of intersection of the asymptotes with the given curve and which are lying on this line. Next we will find out the third point. So in order to find out the third point, we have to again we have to find out the oblique asymptotes. Now how can you find out oblique asymptotes? What is the procedure to find the oblique asymptote? Oblique asymptote can be found out by putting y is equal to m and x is equal to 1 in the third degree, second degree, first degree terms separately. So here you see which are third degree term. Third degree term is xy square minus x square y minus xy square. It is the third degree term. So putting y is equal to m and x is equal to 1 in the third degree terms separately, we are getting that it is 1 minus m square, 1 into m. So m minus m square, that is equal to your phi 3m. On putting y is equal to m, x is equal to 1 in the third degree term, we are getting that m minus m square is equal to phi 3m. Next again we will consider the second degree term. So which are second degree term? These two are second degree terms because xy plus y square. These two are second degree term. So again in putting y is equal to m and x is equal to 1, we are getting that m plus m square, that is equal to your phi 2m. Again, what is the first phi 1m? Again putting in the first degree term, so x is equal to 1, y is equal to m, we are getting that 1 minus m is equal to phi subscript 1m. Now, again we will find out that what is the derivative. That means phi 3m dash m. That means it is the derivative of m minus m square with respect to m, that is equal to 1 minus 2m. So first we have to equate phi 3m to 0. So on equating phi 3m to 0, we are getting that it is m minus m square. M minus m square is equal to 0. So m taking common, it is 1 minus m is equal to 0. So we are getting that m is equal to 0 and 1. So now here you see that if we take m is equal to 0, then we will getting your oblique asymptotes cannot be found out, because if m is equal to 0, then if you take m is equal to 0, then it will be asymptote will be y is equal to c. Y is equal to c means it is a horizontal straight line that we have already obtained. So you need not substitute m is equal to 0. Directly we will put m is equal to 1, because we have already obtained that y is equal to, if you substitute m is equal to 0, y is equal to c, and horizontal asymptote, with that we have get the value of c to be 0. So horizontal asymptote we have already found, we have already obtained y is equal to 0. So you need not find the horizontal asymptote. No, next we will take m is equal to 1. So for m is equal to 1, c is given by the equation minus of phi to m divided by phi 3 dash m. So what is the value of c? So c is equal to your phi to m. Phi to m value is your m plus m square. m plus m square divided by minus of this thing. It is equal to minus of this thing m plus m square divided by phi 3 dash m, that is equal to 1 minus 2m. That is equal to 1 minus 2m. So for m is equal to 1, what is the corresponding value of c? For m is equal to 1, corresponding value of c, that is equal to 1 plus 1, it is 2, divided by it is 1 minus 2, that is minus 1. So its c value is equal to 2. So m is equal to 1 and c is equal to 2. So the equation of the oblique asymptote is nothing but you just substitute the values of m and c here. Then only we can get the oblique asymptote. So on putting m is equal to 1 and c is equal to 2, we are getting the oblique asymptote as y is equal to x plus 2. This is the oblique asymptote. It is the oblique asymptote. It is the oblique asymptotes. Asymptote. Now let us find out that whether this oblique asymptote, let us find out the point of intersection at which this oblique asymptote intersects the line x plus y is equal to 0. We'll find out that at which point this asymptote meets the straight line x plus y is equal to 0. So that can be obtained by solving these two equations. That means the equation x plus y is equal to 0 and the equation x minus y plus 2 is equal to 0. So on adding we are getting that 2x is equal to minus 2, hence x is equal to minus 1. And since x is equal to minus 1, so for x is equal to minus 1, what is the corresponding value of y? Corresponding value of y is equal to your plus 1. Because y is equal to minus x meaning y is equal to 1. So now the point of intersection of this oblique asymptote with the line x plus y is equal to 0 is nothing but that is your minus 1 1. This is the point of intersection. Minus 1 1. So let us find out that whether this point of intersection of this oblique asymptote with this line is minus 1 1. So whether this point is lying on this on the curve or not. So here you see that if we take minus x is equal to minus 1, y is equal to 1, then here it is satisfying because it is x square into y. For x is equal to minus 1, y is equal to 1, then this will be your 1. Minus 1 it is, this is plus 1. Here it is xy is equal to minus 1. Plus y square means plus 1. Plus x is equal to minus 1. And minus y, minus 1. Whether we see that whether its value is equal to 0 or not. So it is 1 plus 1 plus 1, that is 3. Minus 1 minus 1 minus 3. So 3 minus 3, that is equal to 0. That means this is the point which is lying on this curve. So actually these three asymptotes meets the given curve in how many points? In 3 points which are 0 0, 1 minus 1 and minus 1 1. And these 3 points are lying on the straight line x plus y is equal to 0 because coordinates of these 3 points are satisfying this equation. Yes, thank you. So here you see in question number 2I, classify the conic 4x square minus 4xy plus y square minus 8xy minus 6y plus 5 is equal to 0. We know that the general second degree equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. This general second degree equation will represent a pair of straight lines. This equation 1 will give a pair of lines L1 and L2. When it will represent a pair of straight lines if delta, that is your B.Sc, plus twice FGH plus twice FGH minus F square minus BG square minus CH square is equal to 0. So if delta, that means ABC plus twice FGH minus F square minus BG square minus CH square is equal to 0, then this equation will represent a pair of lines. Again, when this equation will represent a circle, this equation will represent a circle if A is equal to B and H is equal to 0. If A is equal, that means the coefficient of x square is equal to coefficient of y square and your H is equal to 0, then this equation will give a circle. Again, when it will represent a parabola, it represents a parabola if your H square is equal to AB and delta is not equal to 0. Delta is not equal to 0. When this equation will represent an ellipse, remember that this second degree equation will represent an ellipse if H square is less than AB and delta is not equal to 0. Delta is not equal to 0. When this equation will represent similarly hyperbola, this equation will represent a hyperbola. Similarly, if H square is greater than AB and your delta must not be equal to 0. So these are the conditions you have to remember. So first of all, here in this given equation, what are the values of A, B, C, F, G, H? So here A is equal to 4 and B is equal to 1 and C is equal to 5 and 2H is equal to minus 4. So H is equal to minus 2. And here 2G is equal to minus 8. So G is equal to minus 4. And 2F is equal to minus 6. So F is equal to minus 3. So first of all, here you see that here what is the value of AB? AB is equal to 4. And what is the value of H square? H square is 4. So since here AB is equal to 4 is equal to H square, so this condition is satisfied. That means H square is equal to AB. And again we have to prove that whether delta is not equal to 0. What is delta? Delta is nothing but it is the value of ABC plus FGH. Delta is equal to ABC plus FGH minus F square minus BG square minus CH square. So ABC means its product is 20 plus FGH means it is 8 into minus it is minus 8, 24 into 2 minus 48 minus F square. A is 4, F square is 9, so minus 36 minus BG square. B is equal to 1 and G is equal to minus 4. G square means it is minus 16 minus CH square. C is 5 and H is equal to 4. H square is 4, so minus 20. So here you see that this sum is never equal to 0. So here we are getting that AB is equal to H square and delta, that is ABC plus twice FGH minus F square minus BG square minus H square not equal to 0. Hence this equation represents a parabola. So this is the answer of this question. Here you see we have to find out y of t, that means a particular solution yt, given that y dash t is equal to 2t I cap plus 3t square j cap, where y of 0 is equal to I cap minus 2 j cap. Now here you see we have to find out the particular solution, that means y of t is equal to how much. So for that, you know that what is y dash t? Y dash t is nothing but that is dy by dt. So that is given to be 2t I cap plus 3t square j cap. So from here we are getting that dy is nothing but that is equal to your 2t I cap plus 3t square j cap whole into dt. Now on integrating both sides, adding a constant of integration c, we are getting that what is the integration of dy is equal to y and integration of 2t that is equal to t square into I cap plus integration of 3t square that is tq, so tq into j cap plus c. So this is the solution y of t, that means y of t is equal to this thing. Here it is given that y of 0 is equal to I cap minus 2 j cap. So since it is given that y of 0 is equal to I cap minus 2 j cap, so we are getting that here, that means y is equal to I cap minus 2 j cap whenever t is equal to 0. So in place of y we have to take I cap minus 2 j cap is equal to, in place of t we have to take 0, so it is 0, so that means it is equal to c. So c value is equal to c value is equal to I cap minus 2 j cap. That means here if you substitute the value of c is equal to I cap minus 2 j cap, so y is equal to t square I cap plus tq j cap plus I cap minus 2 j cap. So that implies that y of t is equal to how much? Y of t is equal to t square plus 1 whole into I cap plus tq minus 2 whole into j cap. So it is the value of y of 2. This is your answer. Thank you.